Good morning. Let's talk about the sense of taste. So, taste is a chemical sense because it relies on chemicals in your food to activate your taste buds. Okay, so a bit of marker here. So you have food chemicals activate taste cells in your taste bud. So here is a drawing of a taste bud. In a taste bud, you have taste cells. These are taste cells. Called your gustatory cells. And these taste cells are linked to neurons, usually bipolar neurons, sometimes even pseudo-unipolar neurons that exit the taste bud. And the taste bud itself has an entry, pore. It's called your taste pore. So the taste pore is what allows for chemicals to enter the taste bud. So your food chemicals from your saliva will enter the taste pore to enter the taste bud to then activate. These are you call your gustatory cells, also called taste cells. And then those taste cells will in turn create messages, impulses in your taste neurons, which will carry the message into the brain. So your taste buds or taste cells only last for about 7 to 9 days. And they're replaced by these what's called basal cells. These cells will turn into taste cells around every 7 to 9 days, if I have it, for 7 to 10 days. Okay. Now your taste buds are housed in structures called papillae. So your papillae on the tongue, mostly on the tongue, house your taste buds. So there are 4 forms of papillae. So this was your tongue here. So here's your tongue. Okay. Back here's your mouth, the throat. So your filiform papillae are all over the tongue. Okay. Filiform. Very common, but these are filiform papillae. These are more for texture. These do not contain, they contain no taste buds. Okay, in the filiform. They're more there for texture, to help you to manipulate your food. And you have your fungiform papillae. These fungiform papillae are more on the tips on the sides. So you may have some down here, like this. Okay. Those are the fungiform papillae. They contain taste buds. Then you have taste buds more on the sides, used more in early childhood. These taste buds on the side, there. Back and sides. Call these your foliate papillae. Then we have some that form a V at the back of the tongue. We call these your valate papillae. And these contain the most taste buds. So you have 4 taste buds: filiform, fungiform, foliate, and what's called circumvallate, also called valate papillae. Okay. And in those taste buds, except for the and in those papillae, except for the filiform papillae, you have taste buds. And most of them are in these back ones, these valate papillae. Now, your perception of taste is based on 5 different types of taste cells. So let's look at those. So your taste cells. You have salty taste cells that respond to things like potassium and sodium in your food. You have sour taste cells, responds to hydrogen ions in your saliva. You have sweet, responds to carb-like things, such as sucrose and fructose. You have bitter, responds to what's called alkaloids or amino or nitrogen-containing compounds, caffeine, morphine. Those things tend to be bitter. And then you have your umami. Okay, that one is based on amino acids in your meal, like glutamate, for example. So each taste cell can only respond to one type of chemical. But your perception of taste is based on how you combine these. For example, on here, there's no taste called delicious on here, but you have that taste in you, at least in terms of how you qualitatively describe your taste experience. It's based on how these fire. Maybe to you, delicious could be 10% salty, 40% sour, 30 sweet, 20 bitter. To you, that's delicious. Okay, but fundamentally, you only have 5 taste cells. 5 types of taste cells that respond to chemicals. Now, once you activate the taste cells, the message is sent into the brain. So let's follow how taste travels up into the brain for you to perceive it. So you begin. So you can begin, say, here with your taste buds here. So the taste buds will activate usually your bipolar neurons. And then those neurons will synapse in an area of the medulla oblongata called your nucleus tractus solitarius, NTS. And by the way, the neurons that carry taste up are usually cranial nerves 7, 9, and 10. 7 from the front 2/3 of the tongue, 9 from the back 1/3 of the tongue, and 10 from your pharynx, your throat area. Okay, those 3 nerves carry your taste neurons up to the NTS. The NTS will send secondary neurons on to an area of the thalamus called your ventral posterior medial nucleus of the thalamus, VPM. This is the thalamus. Remember, NTS is in the medulla oblongata. And then from the thalamus, they go to your primary taste cortex, which is in your insular lobe. Okay? So 3 neuron pathway from taste buds all the way up to your cortex, where it's perceived. Of course, from here, it goes into many different areas, you know, to allow for different things to occur. You may create taste memories, you know, taste linked to other activities that you do as well. So from here, it doesn't stop here. It branches out. But just know for me the first 3 neurons in the pathway. Taste buds to NTS, NTS to VPM, VPM to the primary taste cortex. Okay. And then let's quickly do another chemical sense, or a sense of smell. So your sense of smell, or olfaction, which is also a chemical sense, okay, relies on things entering your nose. So as chemicals come through your nose, through the air, they enter, and then in the top of your nose, or here, you have your cribriform plate of ethmoid bone, and you have these olfactory foramina inside there. Those are holes in the plate. And through those holes, you have your bipolar neurons, the ones that form cranial nerve number 1, your olfactory nerve. Those neurons enter the nasal cavity by passing through the olfactory foramina of the ethmoid bone. And these neurons have on them these little dendrites extensions called olfactory hairs. And so the chemicals in the air called odorants will come up and they will dissolve in the mucus. So these cells are not, they're buried in a layer called your olfactory epithelium. And so chemicals must come in, dissolve in the mucous membrane of the olfactory epithelium to then activate the receptors. So you have receptors on the olfactory nerves. They bind to the odorants, called as odorants. And then those odorants will activate these neurons to send a message in. So once these neurons are activated, then they will pass through the olfactory foramina and synapse into specialized structures called glomerulus. The glomerulus. Okay. And then these glomeruli are housed in a structure called the olfactory bulb. So you have this thing called the olfactory bulb that sits right on top of your cribriform plate. It's the olfactory bulb. Okay, that's where the neurons snap in, and they snap onto other neurons that then go back. Back into the brain as your olfactory tract. So first, these are olfactory nerves of cranial nerve number 1, CN number 1, that snaps in the glomerulus of the olfactory bulb onto other neurons that carry it back to snaps into your primary olfactory cortex, which is in the temporal lobe. Okay. And that's how you handle smells. It's basically a 2-neuron pathway. Again, we have your nerve number 1, bipolar neurons, cranial nerve number 1, where they come in from your olfactory epithelium, and they go to snaps in your olfactory bulb, bulb here, and then from there you have second neuron to your primary olfactory cortex. And that's smell. And smell is not as limited as taste is. You have over 350 types of smell neurons, and it can bind multiple odorants to create almost what's called a smell signature. It's not as clean as taste is. It's a bit more complicated. All right, that's it. We'll pause there.